these sweeteners actually seem to have a metabolic response.
Oh, is this your blood sugar? What's your blood sugar doing?
It says 63, but I feel good. Yeah, so this is like the lived experience with type 1. So 99% of the time, things are pretty good. But here's a scenario where I show up, do something totally different in my lifestyle that has such a potent impact on glycemic control, like the exercise.
Yeah, we had a hard workout this morning.
Yeah, I wasn't going to let Tom smoke my. So either way, so it caused a spike. But the difference in you versus me is that insulin will be released immediately and immediately bring it back up, bring it back down. For me, an insulin I take is about 3 to 4 times slower than anyone else.
Dr. Andrew Koutnik, there's some pretty interesting new emerging stuff coming out in the world of sucralose and non-nutritive sweeteners. You are a diabetes and metabolic health researcher at Sansom Diabetes Research Institute. I mean, this is a lot of your world. And I'm curious, can you tell us a little bit about this kind of recent study that came out on sucralose and what we're learning in humans now?
Yeah, that study actually is a recent study, but not the only study to show its effect. It was a study looking at the impact of sucralose on human insulin resistance. And it didn't look so well for sucralose. But the story on that actually goes back quite a few years, all the way back to some original studies where the idea was, okay, if I have sugar and I can replace it with something that doesn't have the calories of sugar but tastes like sugar, that's a net win. And it probably is. But what started to come out of the literature as people started to consume them more and there was higher levels of adherence is the scientific community got more and more interested. And there started to be studies in preclinical models in rodents looking at high doses of these artificial sweeteners in the diet of animals. And what they were finding is that these animals were developing what were signs of dysglycemia and insulin resistance. And so how would they even study this? They would give glucose and their glucose would go much higher after they were chronically consuming things like sucralose. And there was actually a number of studies that came out in animals showing that repeatedly. Now, for a long period of time, this didn't seem to translate to the real world experience of patients or human beings. And so a lot of people just ignored this. Oh, this is just rodents. Rodents aren't humans. It doesn't translate. However, multiple studies at this point have started to point to the idea that these artificial sweeteners may not be so benign. Okay. And that maybe there is the possibility that when you consume artificial sweeteners, and this study you're referring to was sucralose, and that's where most of the data, maybe negative data, has started to come out on, looking at, consuming over time a volume of sucralose in the diet, which you can get in a lot of, foods or drinks, that this study specifically showed insulin resistance as a result of chronic consumption. It's not the only human study at this point to show that either. What does this tell us? Well, there's a lot that we can learn from this. Number one is that if we're talking about replacing high fructose corn syrup, high volumes of sugar for something that doesn't have the calories of sugar, I think that's a net win. But if you're now going to choose from the suite of sweeteners, and that's really important to, let's say you replaced sugar or high fructose corn syrup to lose weight. Well, obviously you don't want to have those excess calories. It's probably not good for your goal. But now you're over here trying to replace that with something that's analogous to it. What do you choose? And I think that that's a very open-ended question at this stage because a lot of emergent evidence has started to illustrate that maybe not all these sweeteners are the same, and some might actually have detrimental effects on metabolic health in some individuals.
So when you look at metabolic or negative metabolic effect, are we looking at it, and this can be your opinion too, and I can, mention that right out the gate. Is it a cephalic insulin response? Is it actually acting at a cellular level? Like, what does it seem to be, at least in the case with sucralose?
I don't think we fully know that answer right now. With a lot of the major studies that have come out have looked at administration of them and looking at the physiology using like insulin, these things called insulin clamps, which you infuse insulin over time, and you can see this very controlled, rigorous impact of insulin in individuals. So like it's a way of manipulating insulin and really finding out is insulin levels changing with chronic consumption. And so what a lot of these studies have shown is looking at pre and post some type of chronic administration of sucralose. And what they're showing is that in these really refined experimental settings, doing gold standard assessments of insulin resistance, that individuals who are consuming this over time, at least at the volumes they were consuming it at, which is still within what some people are consuming. It isn't, they weren't like blasting these people with ridiculous dosages that no one could consume. Even within that, these reasonable dosages, they're seeing in these physiologic studies insulin resistance. How that's actually happening is very much in question. A lot of what is speculated in emergent evidence out of preclinical models is that it might be changing some of the microbiome composition, and that might be translating to unknown impacts, but ultimately translating to end result levels of insulin resistance at the muscle. How we're getting from A to B to C is still an open question. I don't think that that's a refined science that people are going to say, yes, I completely know. But emergent evidence seems to suggest that a microbiome shift may be facilitating some intermediary step that ultimately leads to insulin resistance. Insulin resistance is often linked to things like inflammation. And so there might be an intermediary impact of things like artificial sweeteners, changing microbiome composition, ultimately changing some degree of inflammatory response, maybe not in all people, but in some people, maybe leading to end stage, what is a sign of more insulin resistance. But again, this all harkens back to this idea of, from a practical perspective, why is someone doing this? Ultimately, all things controlled, you just dump a ton of sucralose in your system. That's probably not a net win. But if you're shifting away from something that was worse, that is probably a net win. But there's also a lot of questions about sucralose is not the only sweetener. In fact, sucralose is, you have artificial sweeteners. Not a lot of those fall into the non-natural category. And then you also have these natural form of sweeteners. And I think emergent evidence is very much suggesting these are not all the same.
No, they're definitely not.
After today's video, I put a link down below for my favorite allulose brand. It's called RxSugar. They've been around for a while. I'm a good friend of the owner, Steve, and he's a really cool guy that put together a real serious dream team when it came down to like medical advisors and advisors in general. So I'm happy to be a part of what they're doing. But there are also some really good tasting chocolate sticks. These are called their Swelthy sticks. Now, they put these out on the market to sort of be an alternative for people to be able to have sort of a candy bar-like thing. The best way that I can compare it, and I have to be careful saying this, is kind of like a Twix bar. That's how they are. They're like a stick, and you bite into them, they kind of have a little bit of a crunch, and they have the gooiness. They've got a caramel flavor, they've got a chocolate flavor, a vanilla flavor, a chocolate mint flavor. My personal favorite is the chocolate caramel one. But bottom line, I put a 20% off discount link. So if you go to rxsugar.com/discount/TD20, which that link is just down below, that's going to get you 20% off whatever you want. But I definitely recommend you try the chocolate sticks, because if you're someone that craves something sweet, you could be literally surprised that when you eat one of these sticks, your blood sugar might even go down if you had it with some sugar. So if you were to eat one of these sticks, possibly with something that had some sugar in it, you might find that your blood sugar stays stable. Not to mention potentially some of the other stuff that I'm talking about here with fatty acid transport. So really wild stuff. So you use the code TD20, and I'm telling you, these things are the closest thing that you're gonna get to an actual candy bar without all the chaos and metabolic distress that comes with a real candy bar. But they also have good stuff too. They have their sweeteners that you can use, like a syrup for coffee. They have their regular stick packs that are just straight up allulose, granulated allulose. So all that is down below. So that link, top line of the description, underneath this video, please check out RxSugar, and also check out the dream team like Dr. Dom D'Agostino and some of the others that are on the advisory board.
You may or may not have seen this. I know there's some literature discussing like the co-ingestion of sucralose with sugar being seemingly not good. Like it seems as though when those are combined, that is even worse than just sucralose alone. Or worse, right? Or worse than just sugar alone. I remember Dr. Kyle Gillette talking to me about this. Like there's actually some evidence there. I don't know if it's just an additional insulin response that happens, like where you're taking in, I don't know if that's the case or not. Have you seen much about that or heard that?
Well, I know in a lot of the studies that have shown these negative responses, and especially initially, have utilized, experimental designs that allow you to co-administer things like sugar with sucralose, whether chronic sucralose administration or just an acute administration, and looking at the glycemic response post that, and it's always higher. So it just experimentally, that is what people are using to actually assess, let's say, the glycemic tolerance, or glucose tolerance test with something like sucralose and seeing negative effects of that. That's actually some of the original data that pointed to this idea that maybe it wasn't so benign. And so I know from an experimental perspective, people have co-administered them just to see the impacts that it can have on things like glucose control, post-oral glucose tolerance tests, which then allude to the idea if you see a higher glucose level, maybe there's insulin resistance. And now we're at the stage where emergent evidence seems to suggest that this is not a one-off report that you're referring to that recently came out, that there's multiple signs of evidence within humans, not just preclinical models, that, yeah, there might be some degree of insulin resistance that is occurring. We don't completely appreciate how that seems to happen. It might be based on preclinical evidence due to the microbiome, which might be playing a role. And I'm just purely speculating here on inflammatory responses, but it's not, I think, a completely settled science at this stage.
Yeah, we definitely underestimate the impact of the microbiome. I think that at least in the layperson does, right? It's microbiome. We don't know much about it. And it's okay. Yeah, it's a pretty hefty lever to be pulling or not pulling. And what's interesting is I'm going to talk about my own anecdotal experience with certain things. This is wild. You being a type 1 diabetic can really appreciate sort of the nuance and my attention here on this.
Yeah.
I found when I'm wearing a CGM, and I've noticed when I wear a CGM, I pay particularly close attention to this, but I had noticed before that in a fasted state, if I had monk fruit, my glucose would drop into the 30s. Found that very, very interesting. And this is pure monk fruit sweetener, not monk fruit erythritol, not monk fruit maltodextrin, pure liquid monk fruit. Not bashing monk fruit. I like monk fruit. I would choose monk fruit any day of the week over sucralose or aspartame, 100%. But I find it very interesting that my glucose would drop so low, indicating that was there potentially some insulin response there? Not everyone has that response. I'm a very sensitive, highly insulin sensitive person. Have you seen anything like that before?
That's an interesting question, because yes, there is some emergent evidence, maybe less so on monk fruit, but maybe some other sweeteners. And so to really help people appreciate the type of sweeteners that are out there, we talked about high fructose corn syrup and sugar. Those fit over here on the high caloric side of things. You know, the more you have, the more calories you get, high sweet flavor. Then you have this category of artificial sweeteners where it's something like a sucralose or an aspartame or one of these other types of sweeteners falls under. Then you have what you're talking about, which is these naturally derived sweeteners, which come from things like fruits or plants. Those come from stevia, that comes from a leaf. You have things like monk fruit, you have things like allulose. Those are the three that are most well-known, that are over the counter, that people can consume, that actually come from fruits or plants. So right out the gate, people often feel more comfortable with these just by the default that they're not chemically synthesized and manufactured. And also the data we're seeing over here on things like sucralose, we're not yet seeing that over here on this side of things. Actually, the emergent evidence seems to suggest that the opposite is happening over here with some of these. Now, there's not as much evidence across all of these together to really understand what's truly going on. But let's talk about some of the preclinical evidence and also some of the emergent evidence that may indicate why these may be distinguishable from this or this category over here. And one great example of that is something like allulose, which is derived from fruit. And in the context of allulose, there was all this emergent evidence that in preclinical models that there might be more to the metabolic effect of these largely non-caloric sweeteners. And keep in mind, stevia, monk fruit, allulose, they're all have a sweet flavor, okay? They all are largely non-caloric, non-insulinogenic, at least that's what we lend to believe because of the lack of glycemic response. And so that's a net win, right? If someone wants to have something sweet, let's say you're struggling with obesity or type 2 diabetes, you want to lose weight, you want to have, birthday cake for your birthday, but you don't want to just load it with sugar, or you want to make, some alternative and lower your calories or something along those lines, these might be a great option. But some of the emergent evidence, particularly in the context of things like allulose, has actually shown that something like an allulose, which is such a unique molecule, if you take fructose, and you take the third carbon and flip the third carbon molecule, it's called a C3 epimer, that you can actually have a lot of the same physiology of fructose being largely non-caloric. And so what we see is that in animals, at least, there were some really well done mechanistic studies showing that consumption of allulose actually causes a vagal nerve response that facilitates an increase in endogenous GLP-1 production. Now, we know that it happens with fructose. So what this is showing is that you take a C3 epimer, which largely makes it non-digestive, largely non-caloric, but you're still having this GLP-1 response, this endogenous GLP-1 response. Well, there's also evidence that it also lowers glucagon, and at least in preclinical models. And we know that there's some evidence that GLP-1 endogenous production can lower glucagon production. So now, with even more emergent evidence, some recently published studies that actually show in these gastric in ex vivo models, looking at the digestion rate, if you co-administer things like rice with allulose, that you actually appear to alter the enzymatic breakdown of things like carbohydrates, slowing the gastric emptying of things like carbohydrates or rice. So when you look at all that together, that seems like a potent molecule for potentially lowering the glycemic response post-meal, allowing for the body to not have as much of a challenge to secrete insulin and maybe keep glucose in the normal range, particularly for people who have, let's say, pre-diabetes, type 2 diabetes, or type 1 diabetes. But where's the human evidence on this, right? It says that it doesn't always translate from mice, and I've done all the way from cells to mice to humans. And what I've seen in the lab is that not everything you do in the cell translates to the mice, and not everything you do in the mice translates to the human, but sometimes it does. And so there were 2 studies in allulose in humans, and both of those studies, the first one being a co-administration with sugar. And if you co-administer allulose with sugar, or just having sugar by itself, that allulose appeared to blunt the glycemic magnitude post-administration. So analogous to an oral glucose tolerance test, where you take glucose, see how high your glucose gets and how long it takes to resolve to normal glycemic levels. Well, it seemed to blunt that quite a bit and appeared to have a neutral or actually lowering of insulin response. So that's very interesting, right? But it's preliminary, right? It's not a gold standard oral glucose tolerance test. We don't know if that would translate, smaller study. But interesting, because it's seeming to suggest that it may be modeling a lot of what we're seeing in these preclinical models, or replicating in the human setting. But there's other study where individuals were actually during Ramadan. They took patients who had type 2 diabetes during Ramadan, where they fast all day, put a CGM on them, and then gave them allulose prior to their feeding window. Now, there's no control over what they were consuming during this feeding window, but one would assume that, they probably were eating similar things in the same person. So kind of a crossover design. And what they were showing is that these individuals, after this prolonged fast, they have allulose or versus don't have allulose, that the individuals who are having allulose with type 2 diabetes were having a lower glucose response. Again, very interesting, but not necessarily ironclad story. But what it seems to suggest repeatedly is that there is this emergent, really well done mechanistic work in preclinical and in vitro models with something like an allulose, which is a very analogous molecule to fructose, but largely non-caloric because you switch the third carbon, and it's this C3 epimer. If people care to know exactly what it is. But I've even tested this on myself. So I have type 1 diabetes, and I was very curious about this. And this is by no means clinical advice or telling one, this is what, this must be a thing. But what I have seen personally is that if I were to take something like an allulose with a meal, and I've actually tested this in kind of a really controlled setting where I've controlled my insulin sensitivity, activity, day of the week, all these controls, and I administer a mixed meal tolerance test, blend the food up so I'm not having all these confounding variables, like what order of the food did you have it in? Did you have the protein first, the fat first, the carbs first? I controlled all these variables, the time of day, the amount, my insulin sensitivity within the day, and actually gave the same amount of food and just took 40 grams of allulose with that meal, with the assumption that, okay, if this is a real response, if it really is having an endogenous GLP-1 response, if it really is lowering glucagon, if it really is slowing gastric emptying, then it should, in theory, lower the glycemic burden in a scenario like me where I have type 1 diabetes, and I use this tool called an automatic insulin delivery system, which automatically controls based on the glycemic amplitude how much insulin delivered. So everything's controlled. I'm removing all my bias from the scenario. And what I saw was a pretty potent reduction in the glucose spike post a meal. This is only like my scenario, and I have type 1 diabetes, so it may not obviously apply to anyone else, frankly. But it does tell an interesting story, and I'm the lived experience of this, that some of these sweeteners actually have potent metabolic effects. Specifically, I know that the data right now in preclinical and some emergent evidence in humans, even my own experience with allulose, is that it seems to potentially help reduce the glycemic burden of postprandial glycemic response. And in my specific case, I also saw a reduction in insulin needs, not just postprandial, but I also saw a reduction in insulin needs when I co-administered with every single meal over 2 straight days. So what that seems to suggest to me is that some of this emergent preclinical data on the glucagon lowering effect may be very real, because we know in patients with type 1 diabetes, they also, besides having dysglycemia, also have a couple other subtle changes. One, their basal levels of glucagon are higher, so you're spilling out more glucose on a regular basis. So you need more insulin on a basal level to maintain normal glycemia. But we also know that postprandial, the glucagon response is higher. So you have more amplitude of glucose release from the liver post-feeding. Well, if you are lowering glucagon at each meal, you're lowering the amount of glucose spillage at each meal. So in theory, you need less insulin to control all the glucose release. In essence, what in the context of something like type 1 diabetes, what this seems to suggest, not a randomized controlled trial to validate this, we don't know that yet, okay, to caveat that, but it's seemingly suggesting in the context of type 1 diabetes that it's frankly normalizing some of the dysregulated incretin metabolic responses we know are occurring in a context such as type 1 diabetes. And we don't yet know if that would fully translate to all individuals. I know for me, it seemingly is suggestive that it might be. But this gets back to your original question, that these sweeteners actually seem to have a metabolic response.
Oh, is this your blood sugar? What's your blood sugar doing?
It says 63, but I feel good. But
you can leave this in.
See. Oh, let me. Give me 1 second. We'll prevent that from being a repetitive thing.
It's gonna go into diabetic coma here on the show.
Yeah, that'd be good. Be good film.
I'd open with that for sure. See.
Yeah. So this is like the lived experience with type 1. So 99% of the time, things are pretty good. But here's a scenario where I show up, do something totally different in my lifestyle that has such a potent impact on glycemic control, like the exercise.
Yeah, we had a hard workout this morning.
Yeah, I wasn't going to let Tom smoke my. So either way, so it caused a spike, but the difference in you versus me is that insulin would be released immediately and immediately bring it back up, bring it back down. For me, the insulin I take is about 3 to 4 times slower than anyone else. So I also lowered my settings. And so as a result, it isn't able to catch that as early. So what it does is it gives all this insulin, but then there's insulin sensitizing response post-exercise and glucose uptake.
Yep.
So what happens with that? Well, now after all this has happened, there's all this glucose uptake on top of insulin sensitivity that the system is not always seeing. So it's not always prepared for, right? So if you give, on a normal day, it's prime for what's happening 90 to 95% of the time. In this scenario, where it went high and then self-corrected afterwards, usually the system is thinking, oh, I need to give as much as I can. This might be, a mismanagement of insulin. In this scenario, a totally different physiology is happening that leads to future insulin sensitivity, a drop, glucose uptake, all happening simultaneously. And so, of course, it's like a recipe for going low, or you can actually also see the insulin on board. So you can see how much is on board on a regular basis. So when you have these kick-in of insulin sensitivity, glucose uptake independent of insulin as well, it's actually been times where I've eaten an entire meal after like an hour and a half run, and it I need no insulin for a meal, 0. Now it's not common, but sometimes it happens.
Yeah.
So,
Wild. Okay. Well, we're leaving all this in. I mean, this is interesting. Seriously, it's good. It's good. Yeah. Just open with you pounding Smarties, but
all right.
Take advice from this guy with no context.
Yeah, they would think, oh, this guy doesn't know what he's doing.
Yeah. All right, we're back after you almost went into insulin shock there, or diabetic coma. All right, where were we?
Yep. So we were talking about the various forms of sweeteners and how all of them don't seem to potentially have the same response. We talked about some of the caloric-based sweeteners. We've also talked about some of the artificial sweeteners and some of these natural forming sweeteners that seem to not be benign and actually might seem to have some potential metabolic benefits. And we talked a lot about one scenario where there's a lot of animal data, ex vivo data, and also some emergent human data, and that's in the context of allulose. And when you ask the original question, you're talking about, hey, I took something like a monk fruit and saw my blood glucose come down. And I think what we have to start appreciating is that some of these might actually have, in many cases, if you say you had obesity or prediabetes type 2 or type 1, some metabolic benefits to them. If you could co-administer a sweetener and it actually lowers your blood sugar level for someone who's struggling with hyperglycemia or variable glucose levels, that could seemingly be a very potent and beneficial thing. Or just lowering the amplitude of a postprandial glycemic response has relevance and importance to overall health for people. So there's one scenario where it can be very beneficial, but nothing's for free in life, right? So you always have to manage, is it add value to your overall health? Do you need something like that? And maybe some people do, maybe some people don't.
Yeah. I want to talk, the one we didn't really talk much about is erythritol.
Yep.
Erythritol, it's come into press over the last year a couple of times. Yeah. And interestingly enough, and I say unfortunately because I think you and I both know that main study was kind of garbage. We could talk about it.
Yeah.
I've seen less and less products using erythritol. I think it scared a lot of people. Like I've seen less. I've seen less erythritol on the market. And but can you just give even molecularly and bringing it, big picture? We don't have to get super granular, no pun intended. But what is erythritol?
Erythritol it fits into the sweetener category. It's used for a lot of low carbohydrate based, let's say cookie or muffin or one of these other alternatives because it tastes a lot like sugar and it can be used for baking. Now, in the context of erythritol, there was a study that came out that had showed that higher and higher levels of erythritol were associated. You pulled samples from subjects, these large epidemiological databases where you have a ton of subjects, they had blood stored, you can pull blood from that and actually assay or measure the amount of erythritol in their blood. And what it showed is that people who had higher levels of erythritol had higher incidences of things like cardiovascular disease or all-cause mortality. And there's a lot that you have to be careful about with that assumption. Why would someone with higher erythritol in their blood maybe have higher risk for all-cause mortality or cardiovascular disease? Why would that be? And so what these researchers attempted to then do was look at, well, first off, if you consume allulose, does that cause, let's say, high levels of allulose? Well, yeah, when you consume erythritol. Misspoke there. If you consume erythritol at high levels, does that then cause erythritol in the blood? And yes, it does. I mean, but that's kind of a no-brainer, right? Yeah. You consume a molecule as long as it can pass the intestinal barrier and get uptake in the blood. What you see in the blood, yes. So no big surprise there. But then they made the association by looking at another step, not in humans, not in a real-world scenario, but in a model system, looked at if I had higher levels of erythritol, would it cause changes in coagulation factors? And they showed, at least preliminarily, that maybe it would. But this was not in a real-world human-based model system. So that caused a huge stir. First, I was in a very reputable, often higher prestige journal. So that always gets people to pay more attention to it. The title of it said that erythritol induced these adverse outcomes, which is that actually what happened? No, because they actually never gave erythritol in human beings to actually show any biological response that had an adverse effect. That was never shown. So what is being taken away from this from a public interest perspective, from a general population news perspective, is not actually what the study showed.
Yeah.
We also know that individuals like patients with diabetes who also have higher levels of inflammation also have higher levels of endogenous erythritol production. So what is that telling us? Well, it's telling us that, first off, the original part of the study that looked at epidemiology showing that individuals with higher levels of erythritol in their blood are associated with worse outcomes from a big picture, big population level, does not actually mean that consuming allulose has adverse effects. It may just mean that individuals who have inflammation, obesity, and type 2 diabetes all have higher endogenous erythritol. Okay, so that you can almost corner that right here. Okay, there's that. That's actually the most likely scenario because the levels of allulose they were showing in there are so subtle and low, they don't match what the pharmacokinetics of someone consuming erythritol would see in their own study.
No, and it's the pentose phosphate pathway. I mean, you're producing erythritol basically when there's, I don't want to say metabolic distress, but essentially in a metabolically deranged person, like that's gonna happen, and that's also going to be linked with poor heart disease risk. And I mean, it just makes sense. And I don't want to think they were playing on that. I want to think that they were more altruistic than that, but I don't know. In the sense that like playing on the fact that people aren't going to know that there's this, PPP, that there's this pathway, and because just for the sake of brevity, the same research group produced something on xylitol just a couple of months ago too. And xylitol is produced via xylitol is a byproduct of, they reproduce it in the body too. Is it also through the pentose phosphate?
I'm actually not familiar with the pathway.
I think it's still through the pentose phosphate pathway. It's a very similar situation. Like they were looking like same thing. Oh, look, it's elevated in rodents. Oh, look, when we consume xylitol levels go up in the blood. Oh, look, these people that have high levels of xylitol in the blood also have poor, I think in the case of xylitol, it was particularly stroke they were looking at. So I don't want to think that like maybe these studies are just nefarious. I like to hope that there's better in the world than that, but at the very least, very poorly misrepresented and titled.
So I will say that one, I have no idea the intentions of the research. I can never speak to that because I'm not in their lab. I don't know. But it's usually not necessarily at the research level, or the researcher level. It's often about how that is portrayed, and a little bit of to be fair, their title was very insinuatory. So there is that, and I don't think the data necessarily supported that. That's at least my opinion. Take it or leave it. But when you have messaging that shows it's suggestive that something like erythritol can have all these adverse effects, and it's such a commonly utilized alternative to sugar in a lot of products, and you can say, oh, it might be linked to these terrible things, man, that's going to get a lot of clicks. Oh man, like I need to go in my cupboard and look like what has erythritol in it. And so, I mean, like it's going to produce clicks, which helps news stay relevant and all these other things. So I don't want to make too many assumptions there other than to say that I'm not surprised. And that's part of the game. Unfortunately, when you're a scientist and you're trying to help people, you're a great science communicator. And so you know this all too well that what you say may not necessarily be what other people said you said. Yeah. Or in this case, what the science showed in this publication isn't necessarily what someone said it is implying it is doing. It at least suggested a negative potential, but left the can of worms completely wide open, unanswered, and completely speculative. So at this stage, we left with basically nothing really from that other than, man, okay, it'd be cool if you did a follow-on study actually administering to humans, which, by the way, isn't that hard to do. It would be very quick and easy. We could, you obviously need IRB, you need a little bit of funding. And you just administer it to, like, say 10 people, look at these same things that they were showing. I mean, that would be very simple to do. Not very much cost at all. And a little surprised it wasn't in the paper, to be honest with you, because of how much resources it would take to do all the other things they did. I'm a little surprised that it wasn't there. But either way, I'm sure someone will do it, and we'll see. We'll see. Does it actually relate, or does it actually translate the way that it has been represented at the stage? I would speculate it, probably not.
Yeah.
At least nowhere near what the insinuation has been on a social front, on a public front. So yeah, erythritol gets a bad rap. Is it fair? I don't think so. At least the evidence doesn't necessarily support it at this stage. We'll see as more evidence comes out. But hey, I mean, if someone wants to be cautionary and be careful, unfortunately, erythritol is going to sit in that bad rap category until someone comes and disproves that. But it's very hard to undo the first to the plate. Once the message is out there, whether it was the right one or the wrong one, that's usually the predominant theme until a lot of work is done to undo it. So unfortunately, that's where we stand. Hopefully this communication will help clarify that a little bit. But I don't want to say the damage is done, but that's kind of how it goes.
But I mean, look at where we are now with, I mean, even, fat is bad, right? It's taken us how many decades to like kind of unpack that a little bit more. Yeah. It's like the when initial first to market makes a big difference in a lot of different categories. Yeah. One more question on this, because I'm genuinely curious. If allulose is essentially just a flipped carbon of fructose, would it technically break a fast? Like, would you be, I mean, is it basically like you're taking in fructose? Like, whereas like if I were to have coffee with like monk fruit, I would consider that probably not breaking a fast. Maybe let's say stevia, given my weird response with monk fruit, but stevia like does practically nothing to me. Stevia is generally like my go-to for like, I actually don't mind the bitter taste to it. Like I think it tastes good in coffee. I think it tastes good in tea. So I like stevia with that. I do like allulose, but I don't consume allulose fasted because I feel like it's still kind of a food in a way, which is actually one of the reasons I also like it. Yeah. Right. Because it's also kind of a food and I think it has great metabolic benefit, but I'm inclined to think that it kind of breaks a fast, but I'm curious your take on that.
It depends on how you're defining the fast. Yeah. If you're defining the fast as how most people define it, which is low glucose intake, which then triggers low insulin release, insulin being the master kingpin of metabolism. So the lower the insulin really causes this metabolic switch, which then causes, increase in epinephrine and glucagon, which then causes lipolysis response. The low insulin facilitates fatty acid oxidation and ketogenesis in the liver. Like all these metabolic switches is a lot of what people are going after when they're going after a fast. So in that context, in theory, no, because your insulin would, in theory, be even less. So you might be augmenting a fast if you're looking at it from that perspective based on what we know thus far. But if facilitating certain metabolic pathways, would you be shutting down things like, PPAR gamma, PPAR alpha, like one of these other AMP kinase or one of these pathways, like AMP kinase specifically, one that's associated with lower energy availability, ATP, ADP type of ratio. We don't know. and we don't know that. But what we do know so far is that it doesn't have a glycemic response based on the evidence we have so far. It's largely non-caloric. It seemingly suggests that it might be lowering total insulin needs. How that might be happening is totally speculative, but if based on preclinical evidence, may be due to lowering of background in glucagon or postprandial glucagon. So this is largely speculative at this stage. We don't really know the answer to it, but I actually think in theory would augment a fast if a fast is defined as lowering glucose needs or glucose in the blood, which then facilitates a lowering of overall insulin requirements. That's the metabolic switch for most people. They're going after a fast. Mm-hmm. But if you define the fast differently, then maybe we have a different conversation.
Yep. Definitely, man. Well, Dr. Koutnik, where can everyone find you?
Honored to be here. Yeah, I try to stay active on Twitter at X, however people define it, AKOUTNIK. I'm also on Instagram, Andrew Koutnik, PhD. I also have a website where I try to put out as many free resources as possible for people who, are just trying to learn more about metabolism or a lot of information about type 1 diabetes, and that's andrewkoutnik.com. So,
right on, my man. Thanks, brother.